Please welcome Knut Moe.
Hi guys, nice to see you all. Spent last weeks in Africa in the jungles dealing with rhinos and lions coming after us on a few occasions. I wanted to share a little bit about that with you guys and just give you a little bit of an update on how this task is being solved. We try to have a new approach on this, and I'm going to show you some approaches to this that combines different technologies into a much more efficient way of doing the whole rhino poaching, countering work. So it's going to show you a short video from this is last week down in South Africa.
Dying all the time. Then I wake, it's kaleidoscopic mind. I never meant to hurt you. I never meant to lie. So this is goodbye. This is goodbye.
Yeah, this is a short introduction to actually handling things down there. It's a huge country, it's a huge continent. And trying to cover it all is kind of a challenge. Just the Kruger Park alone, where we've been dealing, is the size of Israel. So we figured out it's not enough just have one helicopter go up there and try to cover the place. This is a preliminary field report from our weeks down there. Please feel free to ask questions afterwards. I will try to answer them as good as I can. The first thing we have experienced is that UAVs are just 1/3 about flying something. The rest of the time, it's about logistics and data utilization. So it's time you act like that and start to understand that this is not about seeing something fly. This is about actually collecting data and using that to improve your business performance. We were working with a campaign down there called Save the Rhino. This is Nelson. He was unfortunately dropped roughly 8 months ago, so he's gone now, along with roughly 80% of the rhinos in that area. If nothing is done by the next 6 or 7 years, there will not be any rhinos left to future generations at all. RMO Solutions is a solution provider for anything dealing with remote sensing. We're a Swiss company. We deal with UAVs. We deal with any kind of ground sensor to detect what's going out in the field. We are a provider of various solutions, both within perimeter security and these things. I cannot talk so much about that, but I will talk gladly about the rhino poaching. We work within different areas, including air and both fixed wings and VTOLs. We work with ground vehicles and with maritime solutions. Now, to share with you how we deal with this is that we see the UAVs are information collectors. The different remote sensing apparatus is of no use unless you actually process it and use it for something meaningful. So in everything we do, in all solution approaches, we have a information processing part of that task. There is no use in processing it unless you also have some sort of reception on it. So you make sure that the information you receive is processed and sent to the people making the decisions in real time. So everything we do here is in real time with all the complexities that involve. The systems we use for the rhino poaching is complementing what's already in place. So this means that we're not there to remove all the other tasks out there. We are there to complement them and to make sure that we can use even tougher technologies that are always available to catch more poachers in their act of doing their actual deeds. Our remote solutions, we combined all the different technologies into one intelligence stream, which means that you have a lot of devices out there. Combine everything from UAVs to subsurface cables that actually are able to pick up the footsteps of the people walking through the jungle, which is kind of cool. I'm going to show you how we're thinking about this. For instance, in the Kruger part, we used a dedicated area that we wanted to cover, and we expanded that, so we created a perimeter around this area that we were watching closely. We used a combination of flying vehicles, of ground radars, shot detection, and various other devices. To do this, instead of blindly sending UAVs out to try and find, have you ever seen the African jungle? Have you ever been there? Raise your hand. There we go. It's kind of big, isn't it? And it's really, really difficult to see anything at all. So instead of sending UAVs blindly out to find something, you wanted to use detection devices to find out where points of interest or persons of interest would be trespassing in the park. And once we had that position, we would be able to send out a UAV to verify or even show force to the people on the ground, and perhaps even also prevent the actual poachings themselves. To do this, we used some pretty good products. Well, flying is 33% of the work, but the systems we use, they need to be good. So we used a system from Electronics, which enabled us to have extremely good proximity control of the ranges going at it out there. The systems would follow cars, would be on top of the cars to see what's around the cars for a proximity of roughly 1 kilometer, using a combination of thermal and optical sensoring. Furthermore, we used a really good system from CSRL, also here today. We will see just a short video clip here of how that actually works in the field. This was collected roughly 10 days ago at the Makalali Game Reserve. It shows the team setting up the system at dusk, sending it off into the African night. Takes roughly 5 minutes to set up. It's a parachute landing system. And it's launched with a catapult like that. Now that gives us a system that allows us to fly up to 30 kilometers away from our base of operations. Now that's a pretty good chunk of land. It gives us a good thermal view of what's going on. And this is a night operation, so we're doing it at night. And you see here we found 3 rhinos moseying about close to the road where they are going for some eating, basically. So as you see here, even though in the dense underbrush, you're able to easily spot and see your animals down there like that. Furthermore, you're able to even follow vehicles of interest, follow objects of interest on the ground to ascertain what their intentions are and to see how you want to intercept these various objects of interest. In addition, we put sensors on the ranges down there. We gave them a secure voice communication set because the easiest way to avoid the rangers is for the poacher to pick up a radio scanner. You can hear everything's being said. So there are so many completely basic changes to make down there. But this system gave the rangers both the opportunity to collect evidence when they approached at a poaching scene. They would see everything going on and they would collect evidence. So we suddenly had a video evidence of what's going on, which will make the digital process much more easy and much more informed for all people down there. These systems enable rangers to be around in the bush for a week at a time and record things that should be recorded and also stream information back to headquarters in real time. Just push a button. You see the button right to the left here. Just push it and the stream is received on the headquarters within seconds. So it's a pretty nifty solution as well. Looks like this. In addition, we also did gunshot detection, which is a reactive tool when you're dealing with poaching, because once the shot is taken, there's not much you can do for the animal itself, but you can be sure to try to catch the guys who did it. And by deploying a set of audio arrays, you're able to actually vectorize the audio information of shots being taken, and you can triangulate the position of that shot. And that's pretty cool because it means that when you launch that fixed-wing system, it will go straight to that point of shooting, and you will be able to not only get an idea of what's going on because you can put the drone in a on station above the site, but you can also go down to 50 meters just merely above the treetops and show yourself. Remember, this is at night. It's pitch black. There's nothing you can see there whatsoever. But you can also use strobes to mess up the night sights of the poachers down there so they're not able to actually find their way back to where they're coming from and make it easier for the rangers to apprehend them, which is a pretty cool thing as well. So you can not only use the drones for overview, but you can also use it as a show of force to see that you are being watched. And that changes people's behavior. They will become more afraid, they will want to leave the area and want to leave the area quickly. People that leave the area quickly make more mistakes. It's easier to catch them. We also used something called a high-definition ground radar placed high above the surface. You can easily see movements in the park or in the state where you want to be able to go and check what's going on. This is an example. You see a road and you see cars moving on that road. The radar enables you to see all movements and to actually respond to them using UAVs to go out and check what's going on. Looks something like this. For future longer-term projects, we'll also be inserting various cables that gives you the footsteps surveillance that you want. People cross over it and you will be able to actually hear that people are crossing over a line they shouldn't be crossing. To drive all this, we set up a LTE network with 30-kilometer range that gave us a 50 to 80 megabit connection all over the park. It gave us the possibility to stream live video and to have the positioning and the live information from all devices out in this area. And it gave us the possibility to do that securely. Most UAV downlinks today are not secure. They are done on radio frequencies, and that's a major problem, not only for us, but for also law enforcement that needs to have a certainty that the data links are completely tamper-proof and safe, secure. To finalize the setup, we also set up a resource center at the reserve headquarters that gave us total overview of what's going on. And it allowed us to run a system that would give us a complete common operational picture, so we know what's going on, we know what resources we have, and we know where we can allocate those resources quickly. Which would look something like this. So we have a map. We are seeing a car, and we are seeing where in that map that car is actually operating, which gives the operators a much better sense of what's going on. It allowed us to see shots being taken. It gives us the location of those shots and makes sure that we can respond to those threats immediately using the UAVs right away without any kind of hesitation. It even gave the rangers the possibility of just using their cell phones to collect the information and immediately have it show up in the maps. So I'm just going to show you a quick clip here. This is what the system is capable of showing a major strategic map of what's going on in real time. All your capacities are shown in here. All your resources are shown with what area they're covering. This is a UAV covering the ground. You see the video draped on the ground, so we see exactly what the drone is looking at. You see your forces, you see where you have coverage, you see where you don't have coverage. This is incidentally here in San Francisco, just for a show of, just for this show here. And this is what you need. Because once you get into all this big data, you're actually able to start making models and predictions and seeing when do poachers arrive at the site. What do they actually need to be in place? Do they do it on moonless nights, or do they do it with nights with full moon? Is the temperature an issue? Are they always coming in on the same road? Use big data to predict what's going to happen next. And when you collect all the data, you can actually start working with it. And that's one of the big challenges of working with UAVs, because you produce such a huge amount of data when you do this work. And this whole model is future-proofed, because once any kind of new technology shows up around the next corner, which it probably will, we're able to plug that in and use it for the same purpose in the same model and collecting data to the same system. So that was just a background to show you how we actually do this. And the basic model for doing this kind of poaching countering is to detect. As you see here, we use all the detection devices. We have a resource center that processes and visualizes this, so we can actually make ourselves understand what's going on. We observe by using UAVs, by using tactical UAVs to find out what's going on, and we finally decide and act what to do and do so efficiently. So enough talk. These are, you have to excuse the layout here, but this was done on first one plane from Johannesburg to Oslo, then one plane from Oslo to here, so it's a little bit work in progress. It's quite fresh. But these are the raw feeds we received in the resource center. I will try to explain what we're looking at. So first here, we're looking at the strategic view of a fixed-wing system on patrol in Kruger Park. What we're seeing here is not the video feed, but is a map feed that we have the metadata of the position of the drone and where the drone is looking, so we know what you're looking at. I will show you why this is important. And we're able to to map out threats in that area and to make adjustments continuously to make sure that we have a fully understandable operating picture. All the data that you collect here will be in your data warehouse. You will, 2 years from now, you will be able to go back and see where did we fly on April 26th. Yeah, we flew this pattern. And using that data is, as we talked about, highly valuable. You can even also see a quick view of what's going on from the different systems like this. So, For the rhino monitoring, we had a strategic view that would look like this. You see the area, we have some possible sightings of rhinos. You see the position of the drone, and you see where the camera is pointing, so we know exactly what you're looking at. And this is, when you're looking at a forest the size of Israel, it's hard to know what you're looking at specifically, so we need to have map support in order to make this work. Because what you get from a UAV, and this will probably get better down the line, but it will still be something like this, right? It's the middle of the night, it's pitch black, and you're getting a video feed that gives you extremely nice, sharp pictures, but you don't know what you're looking at. But when you put this side by side, it gives a much better understanding of what you're doing, because you will get something like this. And suddenly it starts to make sense, right? Because once, we'll see here, just bear with me for a few seconds. Checking your watch here. Yeah, you're going to be good.
We'll add the button next time.
Just a little longer. Hours of watching this kind of video is fun, right? There you see the rhino down to your left. Now you have a whole pack of rhinos in the center of the image, and you can confirm that you have seen them. The drone is repositioning, and you have the camera back on the rhinos right there. You see the 3 white dots in the middle there? That's the pitch black African night, finding rhinos in the dark. Pretty cool? So in the end, the resource center will get an image like this, where you have the strategic view, you have the view from the rangers on the camera on their jackets, you have the helicopters out there, and you even have the fixed wings providing an image in the control room that looks something like this, but it looks better, of course, when we have the good screens over there. But this is the kind of situational awareness you must have in order to actually make the anti-rhino activities work out. That's how it looks. This is the method I've used, and it's been really working well. And it's what I was prepared to show you today.